this video, we're going to explore how to find all the odd numbers in an array and understand the time and space complexity of an algorithm. Don't worry if you're new to complexity analysis, I'll explain it simple and a clear way. So let's start. So there are four steps to understand the time and space complexity. Step 1, explaining the algorithm. Step 2, code implementation. Step 3, time complexity analysis. And lastly, step 4 is space complexity analysis. So step 1, explaining the algorithm. Here's an example of an array: 4, 13, 6, 21, 8, and 15. Start with the number 4. It's not odd, so we skip it. Next, 13. It's odd because 13 divided by 2 gives a remainder of 1, so we add it to our result list. So our result list so far is 13. Next number is 6. Now we check 6 if it's odd. So no, because 6 divided by 2 has no remainder, so we skip it. So our result list remains 13. Next, number 21. It's odd. Yes, because 21 divided by 2 gives remainder of 1, so we add it to our result list. Our result list so far is 13 and 21. Next number is 8. Now we check 8. It is not odd because 8 divided by 2 has no remainder, so we skip it. So our remain result list is 13 and 21. Last number is 15. The number 15 is odd because 15 divided by 2 gives a remainder of 1, so we add it to our result list. So our final result list is 13, 21, and 15. And that's how we find all the odd numbers in an array. We simplify check each number, and if it's odd, we add it to our result list. So next step 2, code implementation. The first line defines a function called find odd numbers, which takes one parameter r or array. Defining a function takes constant time, then the complexity is 1. Line 2, an empty list or odd numbers is created to store the result. Allocating an empty list takes constant time, then the complexity is 1. Line 3, a for loop iteration over each element is the input array R. If R contains n elements, the loop runs n times, then the complexity is n. 4. The condition is checked n times and the complexity is n. Line 5. In the worst case, we append n times and the complexity is n. Last line. Returning a list is a single operation and the complexity is 1. Then the total time complexity is 1 plus 1 plus n plus 1 plus n plus n plus 1 equals On. Next, step 3, the time complexity analysis. Now let's analyze the worst case performance of our algorithm. So, the big O graph representation says that the x-axis represents the number of element n, the y-axis represents the time taken by the algorithm, and the highlighted ON line shows a straight increasing pattern, meaning execution time grows linearly with n. So you wondering why ON? Because we iterate through all n elements, or ON plus 1, and we check if each element is odd or ON. We store the odd numbers On since all the operation run n times, then the final complexity is On. Lastly, step 4, space complexity analysis. In the worst case, all numbers in an array are odd, so we store all n elements in the new list. This gives us a space complexity of ON, or linear. To summarize, time complexity is linear and space complexity is linear.